Welcome back. Today, I'm going to be going over this exponential SAT question. Um, Now, the specific question, right, I got from Anico.ai. So again, thanks for them. Um, you can find that under free resources on their website, right? If you go to that specific tab. But I want to give a chance for you guys to try this problem first before I dive into it. Okay, so here we have a function f of x that is equal to c plus a times b to the x power, right? So essentially there's a lot of constants, right? Right, where a, b, and c are constants, and we have these constraints for b. The table given, right, shows three values of f. So we have it at 1, 3, and 5, right? And our goal here is to find the value of c. So how do we even start? There's a lot of constants in this problem, right? Well, for these questions that have a lot of constants, I think the best way to start is just to look at where you're trying to get to, right? So you're trying to find the value of c. So that means at some point, right, you want everything to be in terms of c, right? Because you're trying to solve for that variable. Now, when I look at this exponential function here, um, what jumps out to me is that, well, there's two terms here, right? There's a c and then there's an a times b to the x. Usually, when you're dealing with exponentials, it's a good idea just to get the a times b to the x part by itself, right? Because that's now purely it's going to be an exponential function, right? So what do I mean by that? Well, if you subtract c from both sides, so you have f of x minus c equals a times b to the x. I think this is much more simpler to deal with, even though it's technically the same thing, because now you just have the pure exponential on the right side, right? There's no constants being added or subtracted. So what I'm actually going to do is create another function called g of x, and I'm going to set that equal to as f of x minus c, right? So I'm going to define that as f of x minus c. And of course, right, we just found out that's a times b to the x. Now, you might be wondering why are you defining another function? You'll see later on why, right? Because now look, right, we're given these three values. You notice that they are evenly spaced apart, right? 1 to 3, 3 to 5, it's a difference of 2, right? That's also going to be important for later on. But we can get three equations from this table, right? We can get f of 1 equals 8, right? Because the value of 1 is 8 for f. Same thing, right? F of 3 equals 20, and f of 5 here equals 44. Now, why is that important? Well, now let's find the equivalent g of x, right? So what's g of 1 equal to? Here, right, g of 1, we defined earlier as f of x minus c. So g of 1 equals f of 1 minus c, right? G of 3 equals f of 3 minus c, and g of 5 equals f of 5 minus c, right? And we already know the values for f, right? These values here, we already found the table. So we can actually say that g of 1 equals f of 1 minus c. F of 1 is 8, so 8 minus c. Likewise, this is 20 minus c, and this is 44 minus c, right? So now, notice how we have kind of everything in terms of c now, right? That's what we want, right? Now, the final step here is to realize that, well, this is a purely exponential function, right? Because remember, g of x is equal to a times b to the x, right? That's purely exponential. Why is that important? Well, let me go off to the side here for a second. Let's say you have an exponential function 2 to the x, right? If you make a table of values, right, at x equals 1, it's going to give you 2, right? 2 gives you 4, 3 gives you 8, 4 gives you 16, right? And so on and so forth, right? Why is this important? Well, look at this, right? You're always multiplying by 2 as you increase your x by 1, right? Which means the ratio between two consecutive numbers is always the same, right? And a key thing to actually realize, right, is a more generic case, which is the ratio between two evenly spaced apart numbers are also the same. What do I mean by that? Well, at 1, 3, and 5, right? If you take the value at 1, which is 2, and go to 3, you're multiplying by 4, right? If you take the value at 3 and you go to 5, well, that's 8 to 32. You're also multiplying by 4, right? So notice again how the ratios are the same. So anytime you have x values, right, that are evenly spaced apart, right, the ratios are going to be the same for an exponential function, for a purely exponential function. Why is that important for this problem? Well, the reason is because we have three evenly spaced out values, right? We have 1, 3, and 5, which means what you can actually do is make a ratio, right? So you can say that g of 3 divided by g of 1 equals g of 5 divided by g of 3, right? Again, this goes back to what I was talking about earlier with the 2 of x, right? 2 to the 1 is 2, 2 to the 3 is 8, 2 to the 5 is 32, right? From 8 to 2, right, you're dividing by 4. From 32 to 8, you're dividing by 4. So again, that's a common ratio. Therefore, you can set these equal to each other because this expression here, right, g of 3 over g of 1 and g of 5 over g of 3, they both have a common ratio, right? So now it actually is much easier now because if you cross multiply, right, you get g of 3 times g of 3, which is, of course, g of 3 squared. So you have g of 3 squared equals g of 1 times g of 5. And what you'll realize, well, we already have the expressions for those, right? Because g of 3 was 20 minus c, right? G of 5 was 44 minus c, and g of 1 was 8 minus c. So what you can do now is substitute those in, right? So you get 20 minus c squared equals g of 1, which is 8 minus c, times g of 5, which is 44 minus c. And how do you find the value of c now, right? Well, it's easy, right? Just I would use Desmos here. So one side you have 20 minus c. I'm going to use x, right? Now on the other side you have 8 minus c times 44 minus c, right? So now when you put that into Desmos, right, your goal here is to try to find the intersection point, right? So if you zoom out, you'll see that they intersect specifically at, let's see, right, -4, comma 576. So they intersect at -4, comma 576. So does that mean c is -4 or 576? Well, c is going to be -4, right? 576, that's just the value of these specific expressions, right? We don't care about the value, we care about c. Think of c as x, right? Because here, right, we used x, right? And we're trying to find where the x intersection is, which was -4. Well, again, right, we use x for c, right? So that's going to be -4 too. And our answer choice here is going to be B. So hopefully this made sense. The key thing to realize about this problem is that anytime you have evenly spaced out numbers, right, for exponential function, you can actually say that the ratios between those two numbers are going to be the same, right? Again, this is only if it's evenly spaced out. If this was 6 instead of 5, this wouldn't work, right? And the other key thing to realize is that anytime you have this weird looking constant function, it's always a good idea just to get that exponential part by itself, right? That usually simplifies things a lot um, later on when you're doing a problem, right? So again, right, hopefully you understood that if you didn't, just leave any comments you have down below. But make sure you hit the like button and click that subscribe, right? We do post videos daily, right, to help you in your ACT and SAT prep. So, of course, if you want to hear when we're posting videos, hit that notification bell too. But once again, I'll see you next time.